Welcome back. We are going to analyze the dot product. The dot product of two vectors, A and V. The dot product of two vectors is a new operation. It's being written like this: A dot V. This is the scalar product or the dot product. Is mentioned these two ways: scalar product of two vectors. And the things about this is a number. So what we want to do is to identify which number is this one, giving A with some direction and giving V with some direction. Let's say that this is the vector A. This is the vector A and this is the vector V. Given the two vectors A and V, meaning two magnitudes and two directions, two different directions, what is this number A dot V? It's an operation. So the definition of the dot product is that A dot V is the magnitude of the first by the magnitude of the second by the cosine of their angle. And the angle that they made is theta, this angle theta. This is the definition. So we have to analyze this definition and think about it. When theta is bigger than 90 degrees, when theta is between 0 and 90 degrees, cosine of theta is positive. So the dot product will be positive. This looks like the work. The force, let's say that A, the vector A is the force, and let's say that the vector V is the displacement. So the dot product is the magnitude of the force by the magnitude of the displacement by the cosine of theta. So this is the definition of work. It's the same definition. So the work is the force in the direction of the displacement, F cosine of theta, by the magnitude of the displacement. Wow! If the cosine of theta is between 0 and pi divided by 2, cosine of theta will be positive, so the force in the direction of the displacement will be positive. While if the cosine of theta is between pi divided by 2, 90 degrees and 180 degrees, cosine of theta will be negative, so this is positive, and this is negative. In this case, in the case that the displacement is going in this direction, and the force is going with an angle that is 100, that is more than 90 degrees, the cosine of theta will be negative, so the force in the direction of the displacement, the Fs, will be negative. This will be negative. So this is F by cosine of theta. This is the force. So let's go to see some property of the dot products to familiarize with this new concept. A dot V is a number, we said that. A dot V is 0 when, well, if A is 0, if A is 0, the magnitude of A is 0, multiplied by something will be 0. So if A dot V is 0, is because maybe A is 0, maybe V is 0, or is because the cosine of theta is 0. Or if the cosine of theta is 0, means that the angle is pi divided by 2, because the cosine of an angle is 0 when theta is pi divided by 2. The other thing is, if we make the vector directional unit vector I dot I, what it will be? Applying our definition of dot product will be the magnitude of I by the magnitude of I by the cosine that they make. The angle that make I with I is 0 by the cosine of 0. Cosine of 0 is 1, so the magnitude of I, 1. The magnitude of I, 1. Cosine of 0, 1. So I dot I is 1. What if we do I dot j? It will be applying our definition, the magnitude of A by the magnitude of the second, G by the cosine of the angle. But now the angle that they make I with J is 90 degrees. So I dot J is 0 because cosine of 90 is 0. So I dot J is 0. What will be A dot B? A dot B will be the magnitude of A by the magnitude of B by the cosine of theta. Using the angle theta equal alpha 2 minus alpha 1, where alpha 2 is the angle that the vector V does, and alpha 1 is the angle that the vector A does with the positive x-axis, we can conclude, and knowing this relation, trigonometric relation, that cosine of theta, cosine of alpha 2 minus alpha 1, this is theta, this is alpha 1, this is alpha 1, and this is alpha 2. The angle of the vector V, the A, and the V, this is the vector V. What is the angle that they made? Theta. What is the angle that they made between them? Is theta. What is the angle that makes with the x-axis the vector A? Alpha 1. What is the angle that makes the vector V with the positive x-axis? Alpha 2. What is the angle between them? Alpha 2 minus alpha 1. What is cosine of alpha 2 minus alpha 1? What is cosine of theta? Cosine of alpha 2 plus cosine multiplied by cosine of alpha 1 plus sine of alpha 2 multiplied by sine of alpha 1. This is a trigonometric relation. So the equation A dot V, that is the magnitude of A by the magnitude of V by cosine of theta, this is the definition is here, can be written if I write cosine of theta like this. So I can reorder this equation like magnitude of A by cosine of alpha 1, put it here, magnitude of V cosine of alpha 2, put it here, and similar like this. If you reorder this equation, you will find that A dot V is also AX, because magnitude of A cosine of alpha 1 is AX. Magnitude of V cosine of alpha 2 is Vx, this is AY and Vy. So what we have proved is that A dot V can be written also like AX, Vx plus AY, Vy. So if A dot V is positive, it's because the angle is between 0 and pi divided by 2. If A dot V is negative, it's because the angle is between pi divided by 2 and pi. Okay, this is an example, a picture of the angle theta that is bigger than pi divided by 2, so A dot V will be negative. If this is the displacement and this is the force, it says that F dot S is negative. This is what it says. Okay, so one example. Let's say that F is the force, is the weight. So the weight will be, the expression of the force will be minus mgj. And let's say that the vector V is delta r, that is the displacement. The displacement is, this is delta S. The displacement is delta x in the I direction plus delta y in the j direction. Delta x in the I direction plus delta y in the j direction is delta r or delta s. If you prefer the displacement, if you want to call it delta s, you can call it also delta s. So the force is going downwards. The displacement is going in this direction. The force that is in the direction of the displacement is this force, this one. So the working going from A to V is negative, because the force, if you go from A to V, far away in the displacement, in this direction, the displacement will be negative because the force is in the opposite direction of the displacement. Well, let's go to do it using the dot product. The force, magnitude of F, magnitude delta S by cosine of theta. Magnitude of F, magnitude cosine of theta by delta S. This is magnitude of F cosine of theta is the force in this direction of the displacement. This is negative by the magnitude of the displacement. So this for sure will be negative. It will be the magnitude of F by the cosine of theta, but the cosine of theta will be negative because it's bigger than pi divided by 2. So this work will be negative. How to do it with vectors? If we do it with vectors, it will be even easier to do it. It will be minus mgj, the force, dot, displacement, delta xi plus delta yj, minus mgj, scalar I, 0. Oh, j scalar I. It will be minus mg delta x, applying distributive property. Minus mg plus delta y, minus mg plus delta y, g scalar j. But j scalar j is 1. So it will be the work in going from A to B. It will be minus mg multiplied by delta y. But delta y is y2 minus y1. With this minus sign is mg y1 minus y2. So delta y is y2 minus y1. So minus delta y is y1 minus y2. Okay, so I wrote this equation. I wrote it like mg y1 minus y2. Okay, let's go to do one numerical example to practice. Let's say that you have the force mg minus 20 joules, minus 20 newtons in the j direction. Let's say that the mass is 2 kilograms, the g is 10, and let's say that you displace in the direction 3i plus 4j. What is the direction 3i plus 4j? Is this direction 1, 2, 3, 1, 2, 3, and 4. You displace in this direction. In this direction you are displaced. So the problem say, what is the work done? Well, the work is the force dot the displacement. I can find the work by doing fx delta x plus fy by delta y, because I have proven that this is the dot product of two vectors. Fx, 0. Delta x, I don't care. Fy, minus 20. Delta y, delta y. Let's say that delta y, you go find the work when you displace how much? You display delta y 4 meters. So this is your displacement, 4 meters. So it will be minus 20, the Fy minus 20 by delta y. Delta y is 4, so the work is minus 80 joules. The work done by this force, that is the weight mg minus 20j in the j minus j direction, to displace the object in the direction 3i plus 4j, the work is negative, is minus 80 joules. Let's go to do it in the way that we used to do it in class. The work is a little bit more sophisticated, what we do in class. So what I want you to prove you that using the dot product is a good tool to find it. The work is the force in the direction of the displacement by the displacement. The force that is on the direction of the displacement is mg, so I'm looking for this force, mg by cosine of theta. Theta is the angle that makes the displacement with the mg. Don't confuse with this angle here. This is the dot product. And this is the force in the direction of the displacement is mg cosine of theta multiplied by the displacement. Now, how I will find the angle theta that they made? Well, the angle theta that they make is the angle alpha plus 90 degrees. Do you agree? Theta is the angle alpha plus 90 degrees. So alpha, the tangent of alpha is 4 divided by 3, is the displacement, is delta s, is 3i plus 4j. So tangent of alpha is 4 divided by 3. So alpha is 50 degrees. So theta is 50 degree plus 90, so it's 143 degree. So I will go to my equation for the work. The work is mg cosine of theta by delta s. So it will be m2 g10 cosine of theta, cosine of 143. And the amount of displacement is, because the displacement is 3I plus 4j, the amount of the displacement will be a square root of 3 squared plus 4 squared, which is 25. Square root of 25 will be 5. So it will be 2 by 10, 20, cosine of 143 by 5. 20 by 5, this 5, by cosine of 143. But cosine of 143 is an angle that is bigger than 90 degrees, so this is negative. So it will be 100, 5 by 20, 100 by cosine of 143, cosine of 100 minus 0.8. So 100 multiplied by minus 0.8 is minus 80 joules. And you have exactly the same answer that you had before, minus 80 joules. So the work done by this force, the weight, is the force in the direction of the displacement, this force, Fs, in the direction of the displacement. This force is in the opposite direction of the displacement, so it's a negative force, of course. So that's why the work is negative. And finally, you do this example, given two vectors A and B. These two vectors, 3I plus 4j, 3I plus 4j, 3I plus 5j. Okay, what is this angle theta? So how you will do? You will do A dot V equal magnitude of A by the magnitude of V by the cosine of theta. The magnitude of A, I know, a square root of 3 squared plus 4 squared. The magnitude of V, I know, the square root of 3 squared plus 5 squared. The cosine of theta, I don't know. I'm looking for the angle theta. So, to what it is this? Is AX, BX, plus AY, VY. Wow. What is AX? 3, BX, 3, plus AY, 4, VY, 5. 3 by 3, 9, plus 20, 29. So 29 is the square root of 3 squared plus 4 squared, 16 plus 9, square root of 25, plus a square root of 9 plus 25, cosine of theta. Oh, done. Cosine of theta equal 29 divided by the square root of 25, 5, multiplied by the square root of 29. So theta, so this will be less than 1 for sure, and theta will be arc cosine of these amounts, and you will find the angle. So do it. Do it by yourself, and you practice how to find angles between two vectors. That's all.